Greetings, salutations, all those nice things. It's me, Mr. A, and right as I started this video, I realized I'm out of water. Like, not that I'm literally out of water and I can't get any more ever, but just there's an empty glass in front of me, and the sink is real hecka far right now. Life's tough. I'm tougher. Let's go. This is the last little bit of topic 10, function operations, and it's the one that's a little bit different. Not gonna lie though, it is legit my favorite. This part 5 is composite functions, and that's where we're taking functions of functions. There are ways to do this graphically, algebraically, but my focus is going to be on the algebraic aspect of it. We're going to look at how to evaluate functions of values. We're going to look at how to make functions of functions, get their algebraic expressions. And of course, in that, checking out their domain, and then maybe a little bit of working backwards. It's going to be moderately exciting. And let's see a couple ways to do this. If we have something like this, we have f of g of 1. That is what that says. Because this says f of, this says g of, this says 1. These don't say anything, but they're necessary for notation purposes. So f of g of 1 is what we're dealing with. And if you want to deal with that, if you want to evaluate it, one way you can do so is first just look at the inside. Just look at g of 1. G of 1 equals something. Well, g of x is x squared minus 1. So g of 1 is 1 squared minus 1. We know this from when we were first introduced to function notation. We're just replacing the x with whatever x happens to be. We evaluate that. 1 squared minus 1 is 0. But we were never after g of 1. We were after f of g of 1. Oh, it just snuck up on us like that. Oops. If we want to find f of g of 1, that's the same as finding f of 0. Because g of 1 is equal to 0. Well, then we can just sub that right in. F of x is 2x. F of 0 is 2 zeros. And that's just from pulling this definition of f of x into there. And 2 times 0 is 0. Therefore, f of g of 1 equals 0. I'm going to do the next one in the same way. And I'll show a different style for how you say examples C and D here. But going from the inside out, I can first evaluate what g of 2 actually is. G of 2 is 2 squared minus 1. So that's like 3. Therefore, f of g of 2 is going to be the same thing as f of 3. Because g of 2 is the same thing as 3. My goodness. Well, I can find f of 3. F of x is 2x, so f of 3 is 2 3s. And that's 6. Cool beans? I can write they're cool beans. Beans. Excellent source of protein. For example C and D, like we can absolutely approach these in the same way. You're comfortable with approaching it the same way? Approach the same way. Go for it. But alternate ways to do that substitution in that kind of same step. You want to find g of f of 1. Replace f of 1 with the formula for f of 1. f of x is 2 times x. F of 1 is 2 times 1. And then we're evaluating from this point forward. 2 times 1 is 2. And g of 2 is 2 squared minus 1. That's how I'd process that while keeping the whole thing intact. So it's just one whole thought process the whole way through. There's no kind of side tangent like, well, this is this scenario, therefore this other scenario is this. Similarly for this last one, g of g, well, it's not even f in here. Gracious. G of negative 2 is the same thing as negative 2 squared minus 1. Therefore, g of negative 2 is equal to g of that whole thing. Negative 2 squared minus 1. Boom. Again, it's a real order of operations thing. You go from as far inside the brackets as you can, you work your way out. Negative 2 squared minus 1 is 3. And g of 3 is 3 squared minus 1. So in terms of evaluating, that's what we got. It's pretty neat. Over here, we're going to look at just getting equations for composite functions. Now the order does matter. Here we've got f of g of x, here we've got g of f of x. They are two different things. Order matters. In the first case, we have, oh, you're right, we should do a color change. Oh boy. I don't know. F of g of x equal to something. What I'm going to do first is replace g of x with x squared. So I'm going to take that and stick it in there. So I have f of x squared. What do I do with that? Well, if f of x is root of 1 minus x, I'm just going to change all those x's into x squared. So here I have root of 1 minus x squared. The domain of that. Well, domain of g is all reals. The domain of f says it can take on anything as long as, how you say, x is less than 1. Can this take on anything where x is less than 1? Hard no. For example, if x is 6, then we have the root of 1 minus 36. That's the root of a negative number. And that's bad. So carefully consider what's permissible. Like the overlap has to be considered too. We do have to consider the domains of the originals. But check out that composed function and see if any new restrictions have been thrown in based on its composition. In this case, if you need 1 minus x squared to be positive, because as we all know, you can't take the root of a negative, you can do some side work somewhere. You can say like, oh, I don't know, I don't want to use that color. Help. You can say that 1 minus x squared has to be greater than or equal to 0. You can say that 1 has to be greater than or equal to x squared. Where's that going to happen? You can use any solving quadratic inequality skills you have from last year. But at some point, you should get that x has to be between negative 1 and 1. And if x is more than 1, then x squared is going to be bigger than its original, not equal to. So the domain of this is that. In the other order, where we're taking g of f of x, we're going to process this the same way. F of x is the root of 1 minus x. So I'm going to replace f of x with the root of 1 minus x. How do I go from there? G of x says take whatever your input is and square it. So I'm going to take whatever my input is and square it. Well, that's just going to give me 1 minus x. Whoa, I guess we're done. Hey, that looks linear. All real numbers, right? No. Also, honestly. But it's a math class. I'm just kidding. Hey, for the record, English matters and your spelling matters. Spell things properly. Don't be a weirdo like old Mr. A. That would be weird. So normally this thing, why am I not same color? Come on, aside. Normally, this thing would be all reals. But we did not get 1 minus x under normal circumstances. We got it by processing x within f first and then within g. And the sad fact is that for f of x, x has to be less than or equal to 1. If we take anything that's outside of that span, then f doesn't exist. How can you process g of f of x if f of x doesn't actually exist? It don't make sense. Therefore, for this one, we can only go and take values that are less than or equal to 1. As with previous lessons throughout this whole topic, interval notation, set notation, you can pick and choose. This is your adventure. But go with whatever works. Cool beans. Wicked neat. Doo-doo-doo-doo-doo. We're going to look at this one. I'm going to tackle it just ever so slightly different in terms of when I sub things in or the order I sub things in, which function I'm processing first, that kind of jazz. So we need f of g of x. What's this? Some sort of new notation? I've never seen that before in my life. I'm just going to assume it means f of g of x. We'll pretend this little, I think it's a tiny little o that means of. So it's like, top O, morning. Anyways, f of g of x is what that says. That's what we're finding. So if we're finding fog of x, which is again f of g of x, I'm going to say, well, f says take log base 2 of whatever our input is. So we're going to take log base 2 of g of x. And the reason I wanted to show you this in this fashion was just to show that this means that g of x cannot be non-positive. It can't be negative. It can't be equal to 0. It has to be positive because we're taking the log of g of x, whatever g of x happens to be. Now we'll see eventually in this case, g of x is always greater than 0. 2 to the x is always positive. We know that from our exponential functions. So in this case, it doesn't cause a restriction, but we absolutely need to be aware of it. So note what can cause a possible restriction. Even though this particular case works out real cutely. G of x is 2 to the x. What's log base 2 of 2 to the power of x? Well, from our knowledge of logarithms, that's just x. Because g of x is always greater than 0, we have no issues processing log base 2 of g of x. That'll always work out. So the domain of this thing is all reals. That's that. Our final 3 examples involve working backwards. So you're given the composite function. You're asked for f and g that could possibly make those up. And what you want to look for in there are really any operations that exist. Any action that you can perform on a value. You can take the square root of things. You can square things. You can subtract 4 from things. You can put things in an exponent. You can take sine, cosine, tangent of things. You can square them. You can, in fact, throw them into a polynomial. There are options. There are multiple options here. For example, I have the option of letting g of x be x squared. If that's what I'm deciding here, I'll stay on blue, then that means that f of g of x, based on my decision to say g of x is x squared, is the same thing as g of x minus 4. And here's the crazy thing I'm about to do. I'm going to replace g of x with x. And I'll replace g of x with x there too. Bam. So, if g of x is x squared, then f of x is root of x minus 4. This will work. This will ensure that f of g of x is root of x squared minus 4. Wicked neat! It's not the only option out there. You could mess around with this other ways. Pick whatever your heart desires here. My heart desires that color. So I'll show you a couple more. Let's say that g of x is x squared minus 4. Well then, f of g of x is in the square root of g of x. Well, what does that mean for us? I'm going to take all the g of x's, replace them with x's, and then there's that. F of x is just root of x. There's a cute little third option here I'm going to show you, because why not? So here's our cheeky option. Check this out. G of x is the root of x squared minus 4. Because then f of g of x is g of x. But that means that f of x is just x. Aww, isn't that just adorable? It's so simple. It's kind of a little hack you can use if you're ever asked to provide f and g of x to give that composition. Let g of x be the function itself. Let f of x equal x. Shabam. You're done. There's 2 more to try. Don't forget, pause video if you need to. Try them out on your own first. See what you can possibly do. And if you're stuck or you want to check how you did, then keep on playing. I'm diving in now. Here I go. Whee! I see multiple things happening here. I see a sine function in the exponent for this other function. So I could say that one of these is using a trig function, one of these is using exponential functions, and go from there. We are taking 3 to the power of sine of x. And that order of the ofs is what I'm basing things of. I kind of said 3 to the power of sine of x. That's what I said out loud. So in my head, what that means is that this is g of x. This is f of g of x. There's that of, right? So what I'm going to go with saying that g of x is sine of x. And that means that f of x is 3 to the power of that. And if you want to see it broken down, how do we get there? Then we can note that f of g of x is 3 to the power of g of x, which means that f of x is 3 to the power of x. And this last one, ew, it looks gross. But there's this thing that pops up multiple times, this cube root of x plus 1. Honestly, I just want to hide it. Let it remain unseen. I'll just let g of x be that thing. In which case, f of g of x is g of x squared plus 2g of x minus 4. And that doesn't look nearly as bad, but you know what looks even better? Oh my goodness. This thing looks so good. Turning all those g of x's into x's. Boom. This thing is done. Oh, you didn't get to see me put the pen down. I did it with authority. Felt really good about it. Anyways, there is practice work in the textbook. Quite a list. Tackle them. Make sure you're comfortable with function composition. You can guaranteed always expect a function composition question on provincials. Whatever's happening this year. But try them. Let me know, as usual, if you have questions or comments or concerns as you do so. If you want someone to evaluate your work, I can always do that too. With this being the last section of this topic, here's review and questions from the January 2019 provincial, as it's always provided. So here are the ones that are topical. You can check the online marking guide to see how these are marked after you try answering them yourself. If you're unsure as to, like if you didn't get 100% on it and you're wondering how would this be marked, again, send it to me. Let me evaluate it. It's the usual. Be good to yourselves. Drink lots of water. I'm going to go fill up this glass now. I'm really sad it was empty. Well, that was devastating. I'll be fine. I'll survive. First I was afraid. I was petrified.